In the previous video, we looked at Xcode's Instruments tool, and we saw how we could utilize it to isolate memory issues. In this video, we're going to take a look at strong reference cycles and how they can cause memory leaks. We'll then create and identify a memory leak in Instruments. So we've seen how Arc is able to track the number of references, and how when our reference count hits 0, it's able to deallocate our vehicle from memory for us. However, it is possible to write code in which an instance of a class never has strong references. In the following example, we'll see how we frequently create what's known as a strong reference cycle by mistake. Let's open up our previous Xcode project, and we'll add a new class named Driver, which will look like this. We'll create a property that will optionally store a vehicle, and we'll update our vehicle to optionally have a driver. In our view controller, let's add an instance of this new driver object. And we don't need this anymore. Next, we'll add some simple values to our vehicle and to our new driver. So, now we have both vehicle and driver instances that contain references to one another. Here's where we'll create our problem. We'll link the two together, which will cause a strong reference cycle. In viewDidLoad, we'll set our vehicle's driver to Steve, and we'll set our driver's vehicle to Car. To visualize, this is how our strong reference looks between our two objects. Here we have created a recursive strong reference. Of course, this strong reference cycle creates a problem for us. When we set both variables Steve and Car to nil, we'd expect Arc to deinitialize our object to free up our memory. But it doesn't. Let's see if we can isolate this problem by running our application in Instruments. Before we do, let's get rid of the timer and update our button logic. We'll replace our NSTimer variable with a simple Boolean flag named toggle. Next, I'll overwrite my button logic with the following. So this is pretty straightforward. The first time we tap the button, we create our objects, and the second tap sets them to nil. We can go ahead and remove this, and we don't need this bit of code anymore. So let's run our application. Again, we'll show the debug navigator and double-click on memory. We'll click Profile and Instruments, and then click Transfer. We'll see our Instruments panel running our application. We see some activity, but we still have our green check marks, indicating that we don't have a memory leak. Next, we'll click the Stop button in our application. And, as we expect, we see a red X indicating we have a problem. If we double-click on our leak checks, we'll see both our driver and vehicle objects. We'll go back to our All Heap and Anonymous VM pane and run our application again. Click the Display Settings icon, and let's click Mark Generation. This creates a snapshot of our application's memory stats. Let's do this several times, creating multiple snapshots with the Mark Generation button. This will compound our problem. Now let's stop running Instruments and look at our snapshot. Expanding a snapshot, if we look in the list, we'll see an item named memorymanagement.driver and .vehicle. We can expand those and see their addresses, and we can get even more detail by clicking the Details arrow. In the Details pane on the right, click the Extended Details icon to see the stack trace. Notice these three items in black. If we double-click on one, it'll display the code, and now that we've isolated our problem, we can launch Xcode by clicking on the Xcode icon here. In this video, we have sufficiently created a memory leak by creating a strong reference cycle. In the next video, we'll see how we can fix memory leaks in Swift by utilizing weak and unknown references.